So we saw the ray diagrams for convex mirror and concave mirrors. Our next topic is sign convention in case of spherical mirrors. Sign convention means what will be the signs of the magnitudes that we take while solving numericals or any other problems. So sign convention is done according to the new Cartesian sign system. If in maths we have studied that this is a Cartesian plane and this is the origin. This horizontal line is called the x-axis and this vertical line is called the y-axis. So sign convention is done according to this new Cartesian sign system. This is called the Cartesian plane, and sign convention is done due to the new Cartesian sign system. So we see that all the distances which are taken to the right of the origin are positive, and above all the distances taken above are taken as positive. All distances taken below the origin are taken as negative, and all the distances taken to the left of the origin are also taken as negative. So this is the sign convention. In spherical mirrors we do the same thing. Suppose we have a concave mirror here. This is the principal axis, this is the pole, the focus, and this is the center of curvature. Suppose an object is kept here. Suppose this is a ray diagram. We draw a ray diagram when the object is between C and F. So we can see that the object in sign convention, this pole is taken as the origin of the Cartesian sign system. So if the pole is the origin, then this object is kept at the left side of the pole. I already told you that the distance from the object to the pole is called the image distance, or U. So in this case U will be negative, as we can see that if pole is the origin and if the object is kept at the left side of the mirror, then U will be negative. And this image, I told you that image distance or the distance from the image to the pole is represented by V. So in this case V will also be negative. In concave mirror, the distance from the pole to the principal focus is called the focal length, which is represented by F. Since this is also on the left side, it will be negative. Now what about the height of the image? Since this image is inverted, so we will measure it downwards, and we saw that if we measure any distance from downwards or below the origin, then it is taken as negative. So height of image will be negative. Height of object will be positive. Why? Because it is measured upwards above the origin, positive side of the y-axis. So height of object will be positive. So this is the sign convention for concave mirror.
For all the cases is it applicable?
Not for all the cases. When the concave mirror forms virtual image, so height of image will be positive. When the image is virtual.
What will be the image distance in that case?
The image distance will also be positive in case of virtual.
What will be the case of this one? Where should be the object to form it?
To form the virtual image, the object should be between focus and pole. So then the image will be formed behind the mirror, which will be virtual image, and in that case the image distance and the height of image both will be positive. So these are the sign conventions for concave mirror. In the sign convention for spherical mirrors, all the distances are measured towards the pole. From the pole. All the distance are measured from the pole. So this is the origin if we take according to the new Cartesian sign convention system. So this is the sign convention for concave mirror. Now we will see about convex mirror. in convex, we see that in convex and concave mirror, the object is always kept on the left side. So U will be negative in both the cases. We have a convex mirror here. This pole, this focus, this is center of curvature. The object is kept here. So this is we have drawn a case when the object is between infinity and pole. As you can see that object is kept on the left side of the pole. We know this is case of convex mirror. So the object is kept on the left side of the pole, so U will be negative. U will be negative. You can see that the image is formed on the right side of the pole, between pole and focus. So since this is on the right side of the pole, that means image distance or V will be positive here. Now focal length, as you can see, distance from pole to focus on the right side from pole, so that's why focal length will also be positive. Since in convex mirror all the cases form virtual image, so this image, since it is virtual and erect, so height of image will be positive. Since height of object since this object is also erect, so that's why height of object will also be positive, since it is measured above the pole. So this is the sign convention for convex mirror. Now we will see mirror formula and magnification. We have to
leave it this one. You write down this side. There is too much space in there because there is the light is flashing on that one diagram.
Okay.
So
we have seen the sign convention. We should be careful when we substitute the values while solving numericals. We have to put these sign conventions so that our answer is correct while solving numericals. So our next topic is mirror formula. Mirror formula. So mirror formula is what? I told you that image distance is represented by V, object distance is represented by U, and focal length is represented by F. There is a relation between these three magnitudes. What is the relation? 1 by V plus 1 by U is equal to 1 by F. This is the relation. 1 by V plus 1 by U will be equal to 1 by F. This relation is true for all spherical mirrors, for all the positions of the object, for all the cases. This relation is correct. So while solving numericals, this formula or this relation will be used in this chapter. So we have seen this formula. Now magnification.
please define the magnification also.
Yes. Magnification. What is magnification? Magnification is the relative extent to which the size of the image is magnified, or to which the image is enlarged to that of the object. It means that if it is an object and if this is the image, height of image, then magnification tells us that how much this image is big than this object. This is magnification. So magnification can be negative, equal to 1, or greater, it will be lesser than 1. It can be equal to 1 or it can be greater than 1. If it is less than 1, that means the image formed is diminished image. If magnification comes equal to 1, that means the image is same size as that of object. And if the magnification comes greater than 1, that means the image is enlarged. image. So these are the three cases of magnification. These are very important as we determine the height of image or the size of the image from these three quantities. So what is the formula of magnification? Magnification is taken as the ratio of the height of the image to the height of the object. Magnification is represented by small m. So small m, this is magnification, is the ratio of the height of image to the height of object. Or we can say m equal to hi by ho. This is height of image this is height of object and this is magnification. So this is the formula for magnification. Magnification can also be measured by using the image distance and object distance. So if we take image distance and object distance, so m will be equal to minus v by u. This is the relation.
Can they be equal?
What?
Can they be equal? That
What?
is what the ratio, both the ratio you are writing, can they be equal?
Yes,
Okay, write down
they
that.
can be equal.
How can you write? Like h dash by h not h whole you wrote na, and you wrote that is minus v by u. Can they all be equal?
M will be equal to hi by ho.
Okay.
That will be equal to minus v by u.
Thank you very much.
So this is the formula for magnification. Our next topic will be refraction. Refraction. We might have been listening this term refraction from our earlier classes, and we studied one definition that bending of light is called refraction. This is what we studied in earlier classes. But refraction is far more than that. Why does refraction happen? First of all, if we take a glass slab, this is a glass slab. And this is air, for example, and this is glass slab. Suppose a ray of light comes incident to the glass slab, then we will see that suppose this is the normal here, the ray of light, the incident ray will bend towards the normal here, will bend towards the normal, and after coming to the end of this surface, when it again comes into the air, then if this is the normal, then it will move away from the normal like this. Why does this happen? As the incident ray or ray of light comes from air to the glass slab, the speed of the light decreases. Speed of light or c in air is 3 into 10 power 8 meter per second, and speed of light in glass slab is 2 into 10 power 8 meter per second. So when the incident ray comes incident to the surface, and then when it enters the glass slab, the speed decreases from 3 into 10 power 8 meter per second to 2 into 10 power 8 meter per second, and when it comes out of the glass slab, then its speed again get back to normal, that is the maximum speed. So refraction is caused by the change of speed of light in different medium. So we can say that when a ray of light enters from one transparent medium to another transparent medium, then it bends. This phenomena is called refraction, or we can say that the bending of ray of light when entering from one transparent medium to another transparent medium is called refraction. Now,
what will be the angle, which direction it is going to, that is the, no, going to bend, light is going to bend, because the bending of light, what will be the, towards the normal, away for normal, what is the condition for that?
if for the condition is that when the speed of light decreases in the glass slab, its speed decreases, that's why this ray of light bends towards the normal.
Okay, what is the, what
This ray,
what is the rarer medium and denser medium? Is it going to use air?
rarer medium here is air. The medium in which the speed of light is maximum or more, then it is called the rarer medium. In this case, the rarer medium is air because its speed is higher than glass slab, and the denser medium is glass slab because the speed of light decreases when it enters into the glass slab. So air is the rarer medium and glass slab is the denser medium.
If the concept is like that, when light entering from rarer to denser medium, then it bends towards the normal.
Yes.
And when it comes out from the denser to rarer medium,
It bends
goes
away from the normal.
Is it like that?
Yes. So this is the incident ray. And this bent ray, when it bends towards the normal, this is the refracted ray. This is the refracted ray. And when this ray of light enters the rarer medium from denser medium, then this ray of light is the emergent ray. Emergent ray. Now, what will happen if we produce this incident ray here? We can see that if we on further producing the incident ray, these two look like parallel lines. So the emergent ray and the incident ray further produced are parallel to each other, and this phenomena, this is called lateral shift. This parallelism of these two rays is called the lateral shift. Now, if these two are parallel, then this, suppose this is the incident angle of incidence,
Okay.
and this is the angle of refraction, this.
Okay.
So angle of incidence will be equal to angle of refraction, and this angle of refraction, this is the angle of emergence
Okay.
represented by E, and this is the angle of refraction with perspective to the second normal here.
Okay. Okay. That will come to incident only.
Yes. So this incident ray, this incident angle will be equal to this refracted angle, and this emergent angle will be equal to this this angle with respect to the second normal.
Okay.
So this is the whole concept of refraction here. Now, when we talk about refraction, we generally talk about optical density. When we talk about rarer and denser medium, we generally mean optically rarer medium and optically denser medium. Optical density is not same as the mass density. There are various criteria that we use to tell whether a medium is optically rarer or optically denser. If a speed of light is more in a medium as compared to another medium, then that medium is said to be optically rarer medium, and the other medium in which the speed of light decreases, that medium is called the optically denser medium. Another criteria to determine the optical density is the refractive index. So what is the refractive index? Before that, we talked about refraction. So there are two laws of refraction here. Two laws. The two laws are that the incident ray, the refracted ray, the emergent ray, and the two normals all lie on the same plane here. So the emergent incident ray, the
Reflected or reflected?
refracted, because in this case refraction is happening. In earlier cases we were talking about reflection.
So how they are in the same plane? How can you explain they are all in the same plane?
We can see that the incident ray is coming here, then it is bending, this is refracting here, and this is coming down, going along the same plane. It is not diverging here or there. It is coming here, refracting here, and then coming on the same way on the same plane there only. That is why they are on the same plane. So incident ray, refracted ray, normal, and emergent ray all lie on same plane. Another law is that the sine of the angle, the ratio of the sine of the angle of incidence to the sine of the angle of refraction will be a constant. So
Known as what?
that is known as Snell's law. Snell's law of refraction. That is ratio of sine of angle of incidence by the sine of angle of refraction will be a constant. This is called Snell's law. So these were the two laws of refraction and the whole concept of refraction here. Now we will see what is refractive index.
So we'll make the separate video for refractive index.
Yes,
because
yes.
The video is long.